Welcome to this classic re-release of Killer Demos. When this video was shot, the ADAT revolution was brand new, hard disk recorders were very expensive, and analog tape ruled the day. Though digital devices dominate recording today, it's still understood that analog recording is an amazingly smooth, accurate, and sonically pleasing system. So even the analog-specific portions of this tape are pertinent to today's recording. The rest of the techniques and concepts are classic in nature. The fundamentals involved in recording are timeless. That's not to say we shouldn't break the rules in the interest of artistic expression, but this video provides an excellent and very usable set of guidelines. If this information is of help to you, check out the Audio Pro Home Recording course for more in-depth instruction. There are 3 books in this series, each containing 2 CDs full of audio examples, and each with a different emphasis. These books are available at most music retail locations, as well as at booksellers like Barnes & Noble, Borders, and Amazon.com. Portions of the series are also available on the web. Check out the Audio Pro recording course at www.artistpro.com to see this sampling, complete with audio examples and color graphics. Each online lesson even contains a test that's instantly graded and displayed with easy-to-understand explanations. And now, enjoy this classic mix video re-release of Killer Demos, hot tips and cool secrets for the home multi-track user.
Are you confused? Look familiar? Getting just a little frustrated? Do you hate when this happens? Killer Demos, hot tips and cool secrets for the home multi-track user. For the next hour, instructor Bill Gibson will take you hands-on, step-by-step through the recording process, teaching you proven methods and principles that will help you record and produce great-sounding demos in your personal multi-track studio. He'll help you with basic equipment selection, setting up and hooking up your gear. You'll learn important pre-production tips and more about your mixer. We'll go through the recording process step-by-step. Guitars, vocals, drums, keyboards, bringing it all together during mixdown. Plus, Bill will also share the same hot tips and cool secrets used by the producers of your favorite recordings. So let's get started. Here's Bill.
Hi, I'm Bill, and welcome to my home studio. The first thing we're going to talk about is the equipment that you'll need to make great sounding demos. The most important part of your setup is the multi-track tape recorder. It should have at least 4 tracks, and these machines are available in cassette, reel-to-reel, and videotape-based formats. The next most important part of your setup is the mixer. A lot of 4 tracks have mixers built right in. And you'll also need a good mic and a boom stand. You'll want to have a compressor limiter. A multi-effects processor is good for adding delays, chorus, and reverb. I also suggest a good quality near-field reference monitor, and I'll explain more about these later. For recording acoustical instruments such as voice, guitars, and percussion, a good set of headphones is necessary. Once your music is done and mixed, you'll need a mixdown machine to store your mix on. Any good 2-track recorder such as a cassette, reel-to-reel, DAT, or stereo hi-fi VHS will do great. You'll need some accessories such as cables, adapters, speaker wire, cable ties, cotton swabs, cleaning solutions, and last but not least, always get the best tape available. It really makes a difference in the sound of your recordings. If you're not sure about some of the equipment I've mentioned, do what I do. Go on down to your local music store. They'll be happy to show you the right equipment to fit your needs and budget. Now that we've talked about some of the equipment we'll need, let's hook it all together. Since you're going to be spending a lot of time in your studio, everything should be comfortable and efficient. Here in my setup, I can reach everything from right here where I'm sitting. I have my mixer in the center, and I use a near-field reference monitor. Near-field monitors are designed to be placed approximately 3 feet apart and to be listened to from a distance of about 3 feet. I also have my multi-track and mixdown machine mounted on a stand close by. You don't need the stand, but your machine should be easy to get to. By the way, another advantage to keeping your setup tight is that it allows you to use shorter cable runs, not only saving money, but maintaining the best sound quality possible. The different types of cables that you'll be using include microphone cables, quarter-inch phone patch cords like a guitar cord, RCA phono cables like the kind you use in your stereo setup, MIDI cables if your studio includes MIDI devices, and some speaker wire. It's okay to use adapters between cables. RCA, quarter-inch, even microphone cables can be adapted to work together. As long as you have mono adapters with mono plugs and stereo adapters with stereo plugs, everything should be all right. You can pick up any of these cables and adapters at your local music store or electronic supply store.
Hot tip.
Plugging all of your equipment into one outlet will help eliminate unwanted hum and noise. Also, using a surge protector will help save your equipment from damaging power spikes. Something you might want to consider when hooking up your system is the use of a patch bay. We want to avoid having to fish around behind gear to hook something up, so we can use a patch bay to bring all the inputs and outputs to us instead of us having to find them. This is all done by running cables from the back of your gear to the patch points in the back of your patch bay and labeling the corresponding points in front. Depending on how many patch points your bay has, you should include tape recorder, mixer, and effects inputs and outputs, any insertion points available in the board, and any auxiliary sends from the board. Once you have all of your equipment's inputs and outputs close by in a patch bay, it makes the entire recording process a lot more efficient, faster, and a lot more fun. If you're using a small self-contained portable recorder, you probably won't need one. But as your setup expands, a patch bay can become an important and time-saving tool.
Cool secret.
If you can't get behind your gear to see a connection, just use a mirror and a flashlight. It works great. And all you have to do is learn how to read backwards. When connecting your speakers, always use designated speaker wire, which comes in different gauges. And for your home use, a number 18 gauge wire should do just fine. Be absolutely sure that the wire that's hooked to the red post at the output of your power amplifier is hooked up to the red post on your speaker, and also that black goes to black. If you accidentally hook red to black or black to red, then your speakers will be out of phase. Now when speakers are in phase, both cones move in and out together. When speakers are out of phase, one cone moves in while the other cone moves out. And what you'll hear will be unpredictable and inconsistent, especially in the lower frequencies. This might seem obvious, but always make sure that you connect an in to an out or an out to an in. There are many different types of mixers, but their basic principles will be about the same. This is the control center for the entire recording process. So let's take a look at what it can do with your signal. The first thing you'll find on most boards is the input section, which can contain an attenuator, which pads or turns down the signal as it enters the board, a phase control, which does the same thing to your signal as switching the wires on the back of your speaker, the input selector, letting you choose from either mic, line, or tape in. An input or peak LED comes on if your signal overloads. If the LED stays on constantly, adjust your trim so that it only lights up occasionally. If the LED never comes on, turn the trim up to the point where it does come on and back off slightly. A common term on mixers is auxiliary bus, also called aux or just bus.
What's a bus?
A city bus picks up passengers and takes them to a specific location. That's what a bus does on a board. It takes passengers, such as guitars, keys, vocals, or drums, to a destination, like monitors, headphones, and effects. The equalization, or EQ section, is used for cutting or boosting highs and/or mids and lows. The switching, or assign section, is usually used for sending inputs to one or more tape tracks. Bouncing or ping-ponging is also done through the switching section. The on-off switch on some boards is called the mute switch. Solo and pre-fader listen allow you to hear a channel by itself. Pan controls the odd or even track assignment and provides stereo imaging during mixdown. The faders usually double in function, adjusting level to tape when recording tracks and controlling levels from tape, effects, and synchronized MIDI instruments during mixdown. Your mixer may have a monitor selector. This lets you listen to the main mix, tape recorders, or buses. Your board probably has an output stage, which we'll discuss during recording and mixdown.
Hot tip.
Most home multitrack users aren't aware of the importance of a reference tone. Now, a reference tone, which sounds like this, is used to adjust levels so that 0 VU on the board is equal to 0 VU on your multitrack or 0 VU on your mixdown machine. You'll also want to record 0 VU on all tracks of your multitrack for future playback reference, and finally record 0 VU on your mixed master to help in setting levels for tape duplication. Setting levels is very important. So if your board doesn't have one, tone generators are inexpensive, readily available, and are an important tool for making killer demos. There are a couple of things that we'll want to do on a regular basis. We'll need to demagnetize the heads and clean the tape path on our tape recorders. To do this, use at least 90% pure isopropyl alcohol or denatured alcohol. Don't use regular rubbing alcohol though. If our heads aren't clean and demagnetized, we can't produce really killer demos. Simply dip your swab in your cleaning solution or alcohol and clean each head and tape guide in an up and down motion. If color shows, repeat the procedure until completely clean. For rubber and other non-metallic parts, follow your manufacturer's recommendations for cleaning solutions and procedures. After cleaning, I use a handheld demagnetizer. Now first of all, make sure that your tape recorder is off, then turn the demagnetizer on at a distance of about 3 feet from your machine. Move slowly in and cover the entire tape path at the rate of about 1 inch or 2 per second. Now once you get to your heads, make sure that you go up and down each head a couple of times. Keep everything slow and smooth. No jerky motions, and make sure that the power stays on to the demagnetizer. Once you've covered the entire tape path, move slowly away to the distance of about 3 feet again and turn the demagnetizer off. That's all there is to it. Now if you're using a cassette multitrack, you can also just go ahead and use a handy cassette demagnetizer. Good organization and planning during pre-production will streamline the entire recording process. Arranging and preconceiving parts will eliminate wasted time in recording and mixdown, plus your demos will sound a lot more interesting. Now your brain can only understand a few things at one time, so having 10 or 15 different parts happening simultaneously is a waste. Now great arrangements and recordings will usually have 3 or 4 parts, such as percussion, bass, chords, or melody, happening at once with one focal point. Now rather than trying to fill up your arrangement with a lot of different parts, try to make up one good part that has a great sound.
Cool secret.
To paraphrase Quincy Jones, the best songs are still the ones that can be played with one finger on a piano keyboard. In other words, keep it simple. This is a track sheet, which is used for logging what goes on your tape. If we can plan ahead for our final 4 or 8 tracks, we can make it sound like we had a lot more tracks. As an example, if we want a big background vocal sound, we may want to do a rough chord track first, then do 5 backing vocals that can be bounced to one track. Now once we've bounced these vocals down, we can reuse those tracks for some other instrument and get a bigger sound. You can't do that when you've left background vocals for last. Pre-production is the secret. If you have a computer or sequencer, it's possible to have most of your arrangement done and rehearsed before you even start recording. And this may seem dumb, but also be sure to have plenty of tape, computer discs, batteries, guitar strings, drumsticks, and bulbs for your video lights, right, Bob?
Yeah.
Developing the good habit of pre-production can save you tons of money when you get out into the road, where studio time can cost you hundreds of dollars an hour. Let's start recording. In this song, we'll use a MIDI sequence from a computer. A tool like this can give you a bigger sounding demo without having to buy a recorder with more tracks. I've recorded a short sequence for demonstration, and within the sequencer I already have 11 different parts. With most sequencers, there's room for more tracks than you'll ever need.
Bill, can you explain time code to me?
That's a great question. Let me answer that as simply as possible. When your arrangement is complete and ready to record, we use time code to link the sequencer to tape. Now, time code or a sync tone is what comes out of the sync out jack of your computer, sequencer, drum machine, or time code generator, and that's recorded onto one track of your tape recorder. Later, that track is played back to the sync input of your sequencer, which allows your MIDI device to be driven by the tape. There are two groups of time code. With one group called sync tone or sync pulse, you must always start your tape at the beginning of the song in order to get your sequencer to lock into sync. With the other group, SMPTE, FSK, or MIDI time code, you can start and stop tape anywhere in the song, and the sequencer will chase to where it should be and lock into sync. Now, the second group is obviously going to be the more desirable type of code. We are now recording or striping our tape with SMPTE time code. Recommended recording levels are usually -3 to -10, so adjust for your specific equipment. Always use an outside track. When you record next to time code, you run the risk of causing your sequencer to stop or go out of sync, so leave a blank or guard track next to your sync track. This is what SMPTE sounds like. Not good. When it's next to a track you use, it has a nasty habit of bleeding through and spoiling your mix. Now, when I roll tape, the sequence will follow along.
Hot tip.
One of the main benefits in using time code and a sequencer is that you never have to print your MIDI instruments to tape, allowing you to change sounds at any time, even during mixdown. This process is called virtual tracking and is used extensively in today's modern recording world. Before we move on, we're going to take a closer look at MIDI. Now, MIDI is just an abbreviation for Musical Instrument Digital Interface, and the invention of MIDI is what's really allowed us to create a lot bigger sounding demos without having to have more tape tracks. Since one track, the time code track on your tape recorder, can really run all of your MIDI devices. Now, what happens with MIDI, just to get right down to it, is that every time you play a note or press a key on a MIDI keyboard or device, it emits a number, a 16-digit number, a stream of zeros and ones. The computer remembers that number and then later plays that number back into the MIDI device and just recreates your performance. Now, that can happen with one note, or it can happen with a lot of notes. It can happen with program changes. It can happen with almost anything that you can do on a MIDI device. It's a really handy technique to be in control of. MIDI has 16 channels. Now, simply remember that information that's transmitted on MIDI channel 1 will only be received by an instrument that's set to listen to MIDI channel 1. And information that's transmitted on MIDI channel 2 will only be received by an instrument that's set to listen to MIDI channel 2, and on and on and on throughout the entire 16 MIDI channels. Now, when we're connecting MIDI instruments, it's simple. We go from the MIDI out jack of, say, your sequencer to the MIDI in jack of your keyboard, and from the MIDI out jack of your keyboard back to the MIDI in jack of your sequencer. There's also another factor involved in MIDI, and that's the MIDI through jack. MIDI through will just take information that it sees at MIDI in and pass it along unaffected, say to another keyboard, which can listen to it all over again. To start, all you need is a MIDI keyboard. As you expand your system, it's better to add MIDI sound modules and drum machines rather than full keyboards because they take up a lot less space and they're really a lot less expensive. Now, dealing with MIDI can be pretty easy as long as you keep it simple and don't let the MIDI intimidate you. Now that we've discussed some basic MIDI concepts, let's build a sequence and look at some points to consider.
Cool secret.
When laying tracks, a great place to start is with a chord chart, or at least some representation of how long each section is with measure numbers. And we can use this as sort of a roadmap to refer to if we have to start and stop in the middle of our sequence, either while recording or while playing back. Now, this is an example of a simple chord chart. Putting your ideas on paper like this is also a good way to organize your song's structure. Now, most songs contain a verse, a chorus, and a bridge. The verse is usually the part that tells the story. The chorus is the part that contains the catchy and repeated melodic and lyrical ideas, usually referred to as the hook. The bridge is used as an accent or harmonic and melodic diversion from the verse and the chorus, and usually happens once in the song. A common song form is verse, chorus, bridge, chorus, with a repeat and fade on the out chorus. This form works well musically and is easy to follow in a song demo.
Hot tip.
If you're anything like Bob and me, you're probably going to make a lot of mistakes on your chord charts and track sheets. So if you use a pencil instead of a pen, it's a lot easier to keep things neat and legible. Since our song is sketched in, let's sequence a reference harmony part. Now, you may want to start with a reference drum beat or a reference bass part, but in any case, we can use this as a frame to build the rest of the song on. Let's add a bass track to help define some of the feel changes and punches. Sometimes it's tempting, especially in these earlier stages, to want to fill this part up with a lot of notes. Now, I've found that it really works a lot better if we can just keep everything simple, especially at this point. When it's time to build your drum and percussion parts, be aware that these parts are going to define the style and energy of your music. Now, a mellower song is going to have simpler parts that have less edge, and a heavier commercial song is going to have punchier parts and more aggressive sounds. It's always a good idea to create a bass guitar part and a kick drum part that work well together. A lot of times these parts will be playing exactly the same rhythm. In this example, I've used auxiliary percussion to highlight section changes. On the chorus, I've added a cowbell, and on the bridge, I've added a ride cymbal. Pretty simple, but you can do whatever you want just to highlight section changes. Now, if your drum parts are together and punchy, your demos are well on their way to being killer. When your bass and drum tracks are coming together, it's time to create a good harmony part, such as a piano or a synth chord bed. Now, filler parts can be used to fill up the holes in between the vocal phrases, but avoid putting keyboard or guitar fills over the top of vocal phrases. If there are too many focal points, neither ingredient can be understood or appreciated.
Cool secret.
Now that we're building tracks, we need to consider our recording levels. Recommended levels on most instruments is 0 VU with an occasional +1 to +2 VU reading. But if you're using a standard VU meter, keep in mind that this type of meter measures only average program levels, not peaks or fast attacks. Recommended recording levels for percussion instruments can vary. For kick drum, we record at about 0 VU. If the peak light comes on, it's because of an attack that's too fast for a standard VU meter to register. It's okay on kick drum and sometimes snare drum to let the peak light come on occasionally. For snare drum, we record at levels of about -3 VU. For other percussion instruments, such as crash cymbal, tambourine, or cowbell, we record at about -9 to -7 VU. Now the reason for the low level here is also because of an attack that's too fast for the VU meter to register. Recording percussion instruments at excessive levels will not only give you an inaccurate and distorted recording, but chances are you'll probably hear those instruments on the adjacent tracks. Now adjacent tracks are the tracks that are either one number smaller or one number larger than the tracks that you're recording on. Now we're ready to actually start printing or recording instruments to tape. This is where we'll have to take a look at microphones.
Hey Bill, what's the difference between microphones?
Well, the microphones that we use in the studio fit into three basic categories: condensers, moving coil, and ribbon mics. Now condenser mics are the most accurate and give us greater detail from the sound that we're trying to capture. Plus they add less coloration or tone change. Now a condenser is almost always the first choice for vocal miking, guitar miking, pianos, percussion, and really almost any acoustical instrument. Now if you could only afford to buy one microphone, I'd really suggest that you get a good condenser mic for recording. Moving coil mics like the Shure SM57 and 58 are used extensively in live performance, but they also have a place in the recording studio. Now these are the most durable of all the mic types, and they almost always have a point in the higher frequencies where they're more responsive.
What's frequency anyway?
Sound happens in air like waves happen in water, and in fact are called sound waves. Our ears react to these sound waves by being pushed and pulled by the crest and the trough of the wave. Frequency is the number of times that this wave completes its cycle in a second and is referred to as hertz or Hz. Now higher numbered frequencies will have higher numbers. Lower frequencies will have lower numbers. For instance, on a piano, the lowest note has a frequency of about 28 hertz. The highest note on a piano has a frequency of almost 4,200 hertz and is also referred to as 4.2 kilohertz, kilohertz meaning 1,000 hertz, or for shorter, 4.2 K. Our ears can hear a frequency range of about 20 hertz in the low end, all the way up to about 20 kilohertz in the high end. Let's get back to the moving coil mic. Since these mics have a sensitivity in the higher frequencies, they'll give us a sound that has a little bit more edge. Plus, they'll handle more volume before distorting. Moving coils are excellent choices for kick drums, snare drum, tom-toms, electric guitars, or really any instrument that requires a bit of a brutal presence. Ribbon mics have a lot of the same characteristics as moving coils. Although their sound is often perceived as warmer or smoother, we can use ribbons for almost anything, but keep in mind that they are very fragile. It's important to note that these are standard and consistent characteristics of the mic types, but everything we do in recording is really subject to what our ears tell us. If we can remember a few basic principles, then we can make intelligent choices and we can break the rules with more authority. Experiment.
How do I mic these things?
Let's look at miking the kick drum first. If we can get the drummer to take the front head off of the drum, it'll make our job easier and we'll be able to get a punchier, fuller sound. Once the head is off, we'll probably want to put a pillow in the bottom of the drum to help absorb some of the ringing from the head. Keep in mind that anytime we mic a drum, we'll get more attack miking the center of the head and we'll get more tone miking the edge of the head. A good place to start miking a kick drum is with your microphone about 6 inches from the back head and about halfway between the center of the head and the edge. Miking a snare drum is very simple. We can usually get the best sound if we place the mic about an inch in from the edge of the drum and about 2 inches up off of the head. And remember, always keep the mic out of the drummer's way. Mic placement on toms is basically the same as mic placement on a snare drum. To record your cymbals, use a mic or two a couple of feet above the kit. Now if you're trying to record your entire kit and you only have a mic or two, you're going to have to experiment with mic placement. Put a mic in front of the drums, move it around till it sounds best, or put a couple of mics above the drum kit, move those around till they sound the best, or you might even try putting a couple of mics back by the drummer to try and hear the drums from his perspective. For bass, we don't need to use a mic. We can either plug into the instrument input of the board, or we can use a direct box. We can plug the bass into one end of the direct box with a regular guitar cord. We can come out the other end of the direct box with a mic cable and run right into the mic input of your board. Now, direct boxes come in two different forms, passive and active. An active direct box will give you a bigger, rounder, fuller sound in the low end and more clarity in the high end.
When recording my guitar, should I mic the speaker or go direct?
A lot of times, I'll combine the direct and the mic signal. Once I find the blend that I like, I'll print that to either one track or I'll print it to two separate tracks and save the blending for mixdown. Now, miking a speaker is much the same as miking a drum head in that the center has the attack and the edge has the warm tone. A good place to start when miking a guitar amp is about a foot away. That'll usually produce good results. As you move the mic farther away, you hear more room ambience or reverb, and that can be good coloration for your sound. When you move in close to the speaker, it becomes particularly important that you're using a moving coil mic so that you run less of a chance of distorting the microphone.
Hey Bill, how do you mic one of these things?
Well, Pat, we don't usually mic ukuleles, but most of the guitar-like stringed instruments are pretty much the same. Now, if we place the mic directly over the sound hole, we'll end up getting a boomy or bassy kind of a sound. What I found works better than that is to put the mic right over the last part of the fretboard and to put it about 3 or 4 inches away from the neck. That gives us a full sound and plenty of definition in the high end. Ow! Vocal miking techniques vary depending on the type of microphone that you're using. If you're using a moving coil mic like the Shure SM58, you'll want the singer to stand so that the mic is about 2 inches away. This will give you a good full sound. If you stand too far away from a moving coil mic, the sound will be thin and weak in the low end. A better choice for miking vocals is a condenser microphone. This will allow you to get about a foot away from the mic and still have a good full sound. If you want to get closer with a condenser microphone, you need to use the bass roll-off switch. This allows you to turn the bass frequencies down and therefore avoid overdriving the inputs to your recording board.
Hot tip.
When close miking, we run up against a problem with singers that pop their P's and B's. This sounds terrible on tape and it's almost impossible to get rid of in the mix. As a solution, we use a windscreen. You can either use a foam windscreen like this that goes right over the top of the microphone, or you can make your own. Use an embroidery hoop, a nylon, and a clamp. Clamp this onto an extra stand between the vocalist and the microphone, and your problems are solved. It's cheap, it's easy.
Okay, Bill, I've always wondered what's the difference between low impedance and high impedance.
Simply put, impedance is the resistance to the flow of your signal. What we need to keep in mind is that high impedance outputs, like the kind that come out of your guitar or keyboard, need to go to high impedance inputs, like the input to your guitar amplifier or line in the back of your mixer. These connections are usually made with regular guitar cords or RCA phono type cords. On the other hand, microphones are usually low impedance and use a 3-pin XLR connector. If your mixer won't accept a 3-pin XLR connector, you'll need to use a line matching transformer or a direct box to change the low impedance microphone to a high impedance level that can be accepted by the mixer. Now, it's important to use a line matching transformer rather than just an adapter to change the 3-pin XLR connector to a 1/4-inch phone plug.
Alex, I'll take recording for 300. Should I use EQ when recording tracks?
Sometimes yes, and sometimes no. With instruments like voice, piano, or synthesizer, the sound that we get out of the microphone or out of the output of the synthesizer already sounds good, so we probably won't print EQ. With instruments like drums, electric guitar, or bass guitar, we'll probably change the tonal balance either to get an extra crunch out of the guitar or to get an extra roundness out of the kick drum. We may not know for sure if we can get that sound from an instrument until we've EQ'd it. And once we've EQ'd it, we'll print that to tape. Let's look at some specifics about EQ. And we'll start with the kick drum. Close miking any drum, including the kick drum, gives us an abundance of certain lower mid-range frequencies that don't sound good. This kick drum mic has no EQ. That microphone had no EQ or it was flat. What we want to do when we listen to a sound is focus first on the part of the sound that we don't like. If we can turn that down, we can probably expose the part of the sound that we do like. Now let's look at some of the changes we can make using EQ. On a mic'd kick drum or tom-tom, the part of the sound that we don't like is usually between 200 and 600 hertz. Let's listen to the difference that's made by turning a frequency of 360 hertz down on this kick drum. Now let's pick a different frequency, about 300 hertz, and turn it down, and see what difference that makes in the sound. Now a frequency of about 250 hertz, and this is usually the frequency that will work best on most kick drums. You can tell that by taking away those mid-range frequencies, we clean up the sound of the kick drum. Once we've found the frequency that we don't like and we've turned it down, we can start to focus on the frequencies that we want to enhance. For instance, on a kick drum, we might want to turn up 80 hertz slightly to give us a little bit more thump in the low end. We also might want to turn up a range between about 3 and 4K to give us an extra attack. Now I'll turn that 250 back, and I have an attack at 3K, a bump at 80 hertz, and let's listen to the difference that we've made in this kick drum. Once you have your kick drum sounding great, it's ready to print to tape. When we EQ the snare drum, we use the same approach that we used when we EQ the kick drum. We listen for the part of the sound or the frequencies that we don't like and turn them down. Then we listen for the part of the sound that we want to enhance, or the frequencies that we want to enhance, and turn them up.
Cool secret.
Snare drums and tom-toms can have an annoying ring. Most drummers will try to dampen that ring with masking tape or duct tape. And what I found works way better is weather stripping. Try it for yourself. Shaping the sound of your bass guitar is pretty much the same as shaping the sound on your kick drum. You'll probably want to cut some mid-frequencies and boost some lows and highs. But if you've boosted 60 hertz in the low frequencies of your kick drum, you'll want to boost a different low frequency on your bass guitar, maybe 80 to 100 hertz. If you've cut 250 hertz in the mid-range of your bass drum, you'll want to cut 300 to 400 hertz in the mid-range of your bass guitar. And if you've boosted 4K in the high frequencies of your kick drum, you'll probably want to boost a different frequency in the high frequencies of your bass guitar, maybe 2.5 to 3K. Boosting and cutting different frequencies on the different instruments in your recordings will help you maintain a more even tonal balance.
Hey, can you help me make this thing sound better?
Well, Ryan, the first thing I'd suggest is that you get some lessons. But really, if the sound that's coming out of your guitar and your amp isn't good, it's very difficult to get it to sound good in a recording. But if you want more punch out of your guitar, try boosting 250 to 300 hertz. And you'll notice that those are the frequencies that we were taking out of the bass guitar and the kick drum. So we're still maintaining an even tonal balance. If you want more grind or edge out of your guitar, boost 3 to 5K. And the frequencies below about 100 hertz can conflict with the bass guitar and the kick drum. So if we can turn those down, we can clean up the low end of our recording. Acoustic guitar sounds best when we boost a high frequency between about 5 and 10K and roll off or cut a low frequency below about 150 hertz. Now remember, EQing works best if we can turn down or cut the frequencies we don't like and turn up or boost the frequencies we want to enhance. Before we print vocals and instruments to tape, we'll need to involve some signal processing equipment. Vocals, bass, and a lot of other instruments have a wide dynamic range, and in order to keep their levels in check, we'll use a compressor limiter. Now, a compressor limiter is just an automatic volume control that turns down when it sees a certain amount of signal. Let's take a look at how it works. Meter 5 shows my voice without compression. Meter 6 shows my voice with compression. When I speak at a normal level, both meters read about the same. Notice that when I speak or sing louder, the uncompressed signal shown by meter 5 is overdriving and possibly distorting or ruining your recording. But the compressed signal shown on meter 6 is well within normal levels. So let's set the compressor. The control that tells the compressor at what level to start turning down is the threshold. The attack and release controls determine how quickly the compressor turns your signal down and how long it keeps it turned down before it releases. Ratio is the control that determines how far the unit will turn down and is expressed as a ratio. For vocals and bass, the ratio is between 3:1 and 7:1. Any ratio above 10:1 turns your compressor into a limiter. Follow this procedure to adjust your compressor. First, adjust the ratio control. On this vocal, I've selected a ratio of about 3:1. Next, adjust the attack control and the release control. Not too fast on the attack and not too fast on the release. The final adjustment is the threshold control. Adjust the threshold until your unit shows 3 to 6 dB of gain reduction. Earlier, we striped our tape with timecode and prepared our sequence. So let's sync up and print a reference rhythm track. If you're not using timecode, then your reference rhythm tracks are no longer just reference tracks, but contain the final mix of your rhythm section. To get the proper mix, it's very important that you follow the procedures that I'll be covering in our mixdown section. Let's record the rest of our instruments. Normally, at this point, we'd want to record lead vocal or guitar, but on this song, we've decided we're going for a big background vocal sound. Earlier, we stressed the importance of planning ahead, and if we don't record the background vocals now, we won't have enough tracks left to record them on later. We'll record 3 tracks and bounce those down to 1. So, instead of our background vocals taking up 3 tracks, they'll only take up 1.
I want you. I want you. Beside me.
Hot tip.
To get a bigger background vocal sound, try using the pitch control. If you're recording 3 tracks, record 1 at normal speed, record 1 at a slightly slower speed, and record 1 at a slightly faster speed. Changing the speed changes the timbre of each track and makes it sound like you have different singers singing each track. Now that our background vocals are recorded, it's time to bounce them down.
How do you bounce tracks?
Our background vocals are recorded on tracks 3, 4, and 5, and we're going to bounce those to track 1 by assigning them to track 1. This is the point where we make final level adjustments, minor EQ changes. We can also ride the on-off switches to get rid of unwanted noise. It's a good idea to listen to the reference track to be sure that we're getting a good blend. It's also a good idea to just listen to the tracks that we're bouncing to check for details.
Cool secret.
Lead vocals are the most emotional track on your demo, so it's important to create an environment that makes your singer feel comfortable and confident. Dimming the lights or adding a little reverb to the headphone mix can help. Before the session, suggest that your singer get plenty of rest and avoid extremely hot or cold beverages. If there's a problem with a voice, suggest that your singer eats a banana. The oil can soothe the vocal cords, whereas citrus products can irritate the vocal cords. All of these tips can help you get a better vocal performance. So it's time for us to record our lead vocal.
I want you by me. I want you by my side. Beside me, beside me. To feel deep inside my soul. I want you.
On that vocal, I used a compressor with a ratio setting of about 4:1, and at the peaks I was getting about a 6 dB gain reduction. For the guitar track, I'll be using a distorted sound from a pedal effect, a dynamic microphone about a foot away from the speaker, and in the EQ, I've boosted 350 Hz by about 3 dB.
I want you by me. I want you.
Hot tip.
For you heavy-duty guitar players, if you want to get a really big guitar sound, try double tracking. Here's how it works. We just recorded our guitar part on track 3. We rewound the tape, and I've changed my guitar sound slightly. Now I'm going to record the exact same part onto track 4. In mixdown, we'll be able to pan those apart and get a really big, fat stereo guitar sound. A lot of your favorite recordings were probably recorded this way. So our tracks are recorded, our sequence is tweaked, and it's finally time to do the mix down. Now this is the cool part where you really make the magic happen. We're going to start with the drums. Now I've layered 2 sound modules for the kick drum and snare drum, and we're listening to one sound module. This kick drum I'm using for attack, so I'm going to add a little bit of high frequency at about K. On this snare drum, I'm going to clean up the mid-range a little bit by turning down about 200 Hz by about 3 dB. At that point, let's layer the other sound module. I use that to fill out the high end and the low end. I'll add a little bit more edge in the high end at a different frequency, probably about 5 or 6K, and I'm going to tweak the mid-range back a little bit at about 360 Hz. Now these are just slight EQ changes. Once that's sounding good, let's add the rest of the kit. This is hi-hat, crash cymbal, tom-tom, and we'll pan those apart for a bigger stereo image. In EQ, I like to turn the high frequency up at about 8 to 10K to give those cymbals some brilliance, and back off at about 400 Hz on the mid-range. Low end, a little bit of a boost, maybe about 2 dB at 100 Hz. And the drums should be starting to come together. They're starting to sound pretty good. Since our drum sounds are mixed and sounding good, we're going to fatten them up with some reverb. Reverb is used to make your sound bigger, and some of the parameters that we can control are room size, such as a concert hall or a stadium or a phone booth or a bathroom, tone, and reverb time, which is really just the amount of time that it takes the reverb to go away. A lot of drum machine sounds already have reverb in them, but we're going to add some more. Let's do it. First, let's add a small, tight reverb. If we listen to that by itself, it sounds like this. On top of that, we can stack a larger room sound. And it sounds like this by itself. Proper use of reverb can really enhance your sound.
Hey Bill, how can I get more punch out of my bass?
Hey Pete, I thought you were a drummer. But if you were a bass player like your brother Bob here, hey, hit it Bob. There'd be a few different things we could do to that bass to clean it up and give you more punch. First of all, we're running through an active direct box straight into the mixer. An active direct box can give you more punch in the low end and more clarity in the high end. Next, we're going to run through a compressor to even out the level. Now the levels are more consistent and we can hear all the notes better. We'll We'll run the bass through some EQ to clean up the mid-range and add some clarity in the high end. Yeah, Bob. We can also split the bass apart with a delay or a chorus for a stereo sound. Yeah. Hey, Bob, do you know any other licks? Yeah, you just barely know that one.
Hey!
Hey, sorry, Bob. Sounds great. Great job, Bob. Bob. Let's add the bass. We'll keep the bass panned right down the center, and it already sounds good coming out of the synth, so we really don't need to use an EQ. Generally, it's not a good idea to add reverb to the bass because it can muddy up your mix. If we add the lead vocal next and make sure that it can be heard clearly throughout the entire song, we'll know where we can place the rest of the instruments in the mix. A lead vocal needs to be panned straight down the center since it's the main focal point. Now Lynn's voice has a little bit of an edge at about 3K or so I'm going to roll that off slightly, about 3 dB. That's a subtle change, but it's starting to sound pretty good. Mixing is three-dimensional, left, right, and depth. Depth is achieved by the use of reverb or delay, and a delay is just a repeat or an echo. The main parameters that we can control on a delay are the delay time and the number of times that the delay repeats. Now on Lynn's vocal, we're using a single delay or a slapback delay that's about 250 milliseconds long. I'll add the delay now. Now let's listen to the vocal and the delay together.
Inside my soul, I want you by me. I want you by my side, right here beside me.
If we increase the delay length, we can make the sound even bigger. The longer the delay, the bigger the sound.
Cool secret.
To hear the proper balance between lows and highs and instrument levels, it's important to monitor at the proper volume. This can be measured on a sound pressure level meter, and the proper range is between 85 and 95 dB. Now this is a good strong volume, but it's not overly loud. A clean power amp and a good set of monitor speakers can provide that volume with minimal distortion, and less distortion means less ear fatigue. I put my background vocals in the center of the mix, and I've added a little delay and reverb. The EQ on the background vocals should be different than the EQ on the lead vocal so that they can have their own space in the mix. Let's add the chord bed. We'll start with the guitars, and these are the guitars that we double track. I've got one guitar panned hard left and the other panned at about 2 o'clock or just off center to the right. I'd like a little bit more edge out of the guitar, a little more grind, so I'm going to turn about 3 dB of about 3K up, and I'm going to smooth out the sound with a little bit of reverb. The other part of my chord bed is a synth sound, and the two parts work together, the guitar and the synth. And I've got the synth panned hard right and at about 10 o'clock or just slightly off center to the left. For the EQ, I've accentuated that upper brass range by turning the high frequencies up, and I can smooth out the brass sound a little bit by adding some reverb. Not too much, just enough. Let's listen to those parts together. Once those parts are together and they fill out the song, we're ready to add some of the rest of the filler parts or the ear candy. The filler parts on our demo consist of an acoustic guitar, an answer vocal, an organ, a bell sound, and a lead guitar solo on the out chorus. We'll bring these filler parts in and out and adjust some of the other levels to maintain the excitement and energy in the mix. Now if you have too many moves to remember, make a list and reference them to your tape counter. I think we're just about ready to print our mix to the Stereo Master.